Geometry 1, Chapter 4 Test, Topic 12. You should be able to apply a composite transformation when given either a picture or points. So a composite transformation is when you have two or more transformations put together. So maybe you have a translation followed by a rotation, or a rotation followed by a reflection. Two of them in a row applied to the same 3 points. So the first example, apply the following composite transformation to triangle ABC, where A is 6, 2, B is 2, -1, and C is 3, 2. Sorry, -3, 2. And we need to first apply a rotation of 90 degrees around the origin, and then reflect in the line y equals -x. Now, to do a rotation followed by a reflection, you do need to know the rules. So we have the rules here. These are the rules that would be provided on a test or a quiz. We have the rotation rules for 90, 180, and 270, and the reflection rules across the x-axis, y-axis, the line y equals x, and the line y equals -x. So you don't have to memorize these, but you do need to be able to find the appropriate one. Well, our first rule is a rotation of 90 degrees. So the first one we're going to use is this rotation rule right here. Now keep in mind, we got to have some sort of work. We have to have some sort of proof that we're doing this, and just like some insurance in case we make a silly arithmetic mistake. So what I typically like to do is start with A, B, and C. A is the point 6, 2. B is the point 2, -1. And C is the point -3, 2. And we're going to apply the first rule, which is a rotation. Now the rotation rules take the point xy and turn it into the point -y x. That rule is coming directly off of this sheet here. Takes the point xy, changes it to -y, x. So the x and the y switch spots, but then the y also changes signs. So when we apply the rotation, the point A becomes the point A prime. B becomes B prime, C becomes C prime. And we actually apply the rotation. So x and y switch spots. So the 6, the x value, becomes the second number. The 2 becomes the first number, except, remember, the y switches signs. So it becomes -2. The B, the x value goes second. The y value goes first, except the sign is switched, so it's +1. C, same sort of thing. The x value becomes the second number, and the y value becomes the first number, except for the sign being switched. Now that's the rotation, but we still have to do the reflection. So we take those points, A prime, B prime, C prime, and we apply another rule. We apply the rule for the reflection in the line y equals -x. So we go back to our list of rules. Y equals -x. Well, that's this one down here. It turns into -y, -x. So the first number becomes the second number. The second number becomes the first number, and both of them have their signs change. So we take this rule and we write it at the top. -y, -x is the rule. Now keep in mind, that's not referring to this -y and this x. It's referring to these points here, which are x and y. So A prime, we reflect it. It turns into A double prime, B double prime, and C double prime. Make sure you put parentheses for your points. Now we apply the rule. So the x and the y turn into -y, -x, so they switch spots, they switch orders, and they switch signs. So these two numbers switch spots and signs. So the 6 becomes a -6, and the -2 becomes a +2. The 1 and the 2, they switch spots and they switch signs. So the 2 turns into a -2 first, and the 1 turns into a -1 second. -2, -3, they switch spots and switch signs. Since both of these are negative, that turns them both into positive. So our points, A double prime, B double prime, and C double prime, are -6, 2, -2, 1, and 3, 2. Now what this type of work allows is that if for some reason, when you apply the rotation, if any of these points happen to be wrong, this now shows the work for how you get the second point, which would also be wrong, even if you are applying the reflection correctly. Now the other situation is that you might be given essentially the same task, but with a picture instead of points. So apply the following composite transformation to the picture. A translation from xy to x plus 1, y minus 4, and then a reflection in the line y equals x. So my first advice here is to take A, B, and C out of the picture. A, B, C. A is the point -3, 2. B is the point 1, 7. And C is the point 2, 3. Those are the original x and y. And then we take those, and the x and the y, first thing we're going to do is apply the rule x plus 1, y minus 4. So A, B, C turn into A prime, B prime, C prime. And what we're going to do is we're going to add 1 to each of the x values. So -3 plus 1 is -2. 1 plus 1 is 2. 2 plus 1 is 3. And then we're going to subtract 4 from each of the y values. So 2 minus 4 is -2. 7 minus 4 is 3. 3 minus 4, -1. And we know to add 1 and subtract 4 because the rule is x plus 1, y minus 4. But now we need to complete a reflection. So that gives us another column here. And we go back to the rules for reflections. So the rules here, if we're trying to reflect across the line y equals x, that's here, it takes xy and it flips it to yx. So it flips the x's and the y's. So here, it takes the point xy and it flips it to yx. Now keep in mind, these are the x's, these are the y's. We don't go back to the original, we use the x's and the y's from this problem. So A prime turns into A double prime, B double prime, and C double prime. XY turns into YX, so we flip the order. Well, -2, -2 doesn't matter. When we flip the x and the y, we still get -2, -2. So we're missing a parenthesis there. B prime was 2, 3. We flip the order of them. The second becomes the first, and the first becomes the second, becomes 3, 2. And C prime, 3, -1, the order switches, -1, 3. Now these are the points, A double prime, B double prime, C double prime. However, we were given the picture to start with. So we are expected to actually graph it when we're done. So, -2, 2, left 2, down 2, sorry, -2, -2, gives us A double prime. B is +3, +2, so right 3 up 2 is B double prime. And C double prime is -1, 3. So left 1, up 3, C double prime, and we connect them to get our triangle. Now it should be a rigid motion, which means it should be the same shape as it was before. I would say that these look pretty similar. They've definitely been turned or reflected or translated or something. In fact, a translation followed by a reflection. However, it's still, BC is still the shortest side, B double prime, C double prime. A kind of feels the furthest away. It still feels the furthest away here. It doesn't look any bigger, doesn't look any smaller. Looks like a rigid transformation to me.